Your phone never stops moving. It leaves home, crosses a highway, enters a mall, then rides the subway. In 5G, that motion is not just radio noise, it is a first class signal that other network functions can subscribe to. This is UE Mobility Event Notification, the system's way of saying, this device just entered, left, or changed presence inside a defined area, and delivering that fact to whoever is authorized to care. Why does it matter? Session management, policy control, and external applications all make better decisions when they know where a user equipment, the UE, is and how that presence is changing. Without a clean subscription model, every function would have to reinvent location tracking. With it, one core function becomes the single source of truth. In this lecture, we will unpack how the Access and Mobility Management function, the AMF, exposes mobility events, what you put in a subscription, how the AMF actually watches the UE, and three worked scenarios that show the same API doing very different jobs. Start with the cast. On one side sits the AMF, Access and Mobility Management function. Think of it as the network's mobility desk. It already knows which tracking areas and cells a UE is registered in, and it sees connection management state change as the device goes idle or connected. On the other side sits an NF service consumer, a network function that wants mobility intel. The source names three classic consumers: the SMF for session management, the PCF for policy control, and the NEF when an outside application needs a controlled window into the core. The rule is simple. The AMF provides UE mobility related event reporting only to an NF that has been authorized to subscribe to that service. Authorization first, then subscription, then notifications. No free for all location feed. So the architecture is not every function pings the radio. It is authorized consumers subscribe once, the AMF watches continuously, notifications fire when the present story changes. That separation is what keeps the 5G core both scalable and privacy aware. Here is the whole handshake in two arrows. First, the consumer sends NAMF affessing event exposure, ASAMA subscribe, toward the AMF. That request is not a vague, tell me about mobility. It carries five precise knobs: event reporting type, area of interest, event reporting information, notification address, and the target of event reporting. We will open each knob in the next scenes. Second, when the subscribed condition is met, the AMF sends NAMF affessing event exposure attenuate back to the consumer. The notify carries the UE presence in the area of interest and the new UE location. Notice the direction of dependency. The consumer does not poll, it declares interest once. The AMF owns the monitoring loop. That is classic event exposure. Subscribe with intent, notify on change. If you remember only one picture from this lecture, make it this one: NF on the left, AMF on the right, subscribe eastbound with those five parameters. Notify westbound with presence and location. Everything else is detail hanging off that spine. Parameter 1, event reporting type. In plain words, what should be reported about UE mobility? The source gives two clear examples. One is UE location, report where the device is, typically as the location the AMF has from registration and radio procedures. The other is UE mobility on an area of interest, report how the UE's presence relates to a defined zone: inside, outside, entered, left, or presence changed. Why separate these? Because not every consumer wants the same grain. An analytics function might only need course location updates. A zone based service might only care about the Boolean is the UE inside my mall campus, and the moment that flips. Event reporting type is how the consumer scopes the semantic of the feed, before geography and timing even enter the picture. When you design a subscription, start here. If you pick the wrong type, the richest area of interest in the world still delivers the wrong story. Parameter 2 is the star of the show. Area of interest, often shortened to AOI. An area of interest specifies a geographical area inside the 3GPP system. It is not a free-form GPS polygon pasted into the core. It is expressed in network geography the AMF already understands. The source lists three building blocks: a list of tracking areas, a list of cells, or a list of radio access node identifiers, RAN node IDs. Picture a city map overlaid with operator tiles. Tracking areas are large tiles used for paging and registration. Cells are the fine tiles under a base station sector. RAN node IDs point at specific G node Bs or equivalent access nodes. You compose an AOI by listing the tiles that matter for your use case. Example: a stadium event might be 3 cells and 1 RAN node. A regional roaming offer might be an entire list of tracking areas along a border. A factory campus might be a tight cell list plus the indoor RAN nodes. Same parameter, 3 scales. The AMF's job later is presence detection against exactly this list, not against an arbitrary map the consumer drew in an app. That is why AOI is defined in 3GPP identifiers, so monitoring stays consistent with how mobility is actually managed. Parameter 3, Event Reporting Information. This is the control plane for how often and under what condition the AMF should talk back. It includes event reporting mode, the pattern of delivery, such as one-shot versus continuing reports. It includes number of reports, a hard cap so a chatty condition cannot flood the consumer forever. It includes maximum duration of reporting, a time box on the subscription's active life. And it includes the event reporting condition, the trigger predicate. The source's concrete condition example is perfect when the target UE moved into a specified area of interest. That is an entry condition. In real designs, you will also see exit, presence change, or continuous mobility within area reporting, depending on the event type you chose earlier. Think of reporting information as a thermostat and a timer glued to the event type. Without it, subscribe would mean notify me somehow, someday, endlessly. With it, the consumer says, notify me in this mode at most n times for at most t duration, when this condition is true. That is how you keep mobility exposure useful for both a one-time geofence fire and a long-running density study. 2 more parameters close the subscription envelope. Notification address is simply the endpoint of the NF service consumer that should receive NAMAF event exposure notify. In practice, it is a callback URI the AMF can reach, the ship the event here label. Get this wrong and the AMF can detect brilliance all day while your function hears silence. The target of event reporting answers. Whose mobility? The source is explicit. It can be a specific UE, a group of UEs, or any UE, meaning all UEs in scope. That single field changes the product. Specific UE is personalization and per session logic. Group of UEs is enterprise fleets, slices, or closed subscriber groups. Any UE is population scale sensing. Think emergency zone occupancy or citywide analytics via a properly authorized path, often through the NEF when the consumer sits outside the trusted core. Put together, type says what, AOI says where, reporting info says when and how often. Address says deliver to whom, target says about which devices. 5 fields, 1 coherent contract. Subscription is only half the story. How does the AMF actually know? The source is precise. When an NF consumer subscribes, the AMF tracks the UE's location considering the UE's CM state, connection management state, and using NG-RAN procedures in order to determine UE presence in the area of interest. CM state matters because an idle UE and a connected UE are visible through different procedures. In connected mode, handovers and path switches update serving cell knowledge quickly. In idle mode, the network leans on registration updates, tracking area updates, and paging-related behavior. The AMF has to interpret mobility evidence in light of that state, not pretend every device is always in a continuous connected trace. NG-RAN procedures are the radio access machinery on the next-generation radio access network, the 5G RAN. They are how cell and node-level reality reaches the AMF. The AMF does not invent location. It fuses core mobility context with RAN sourced updates, then evaluates presence against the subscribed AOI list. So monitoring is not a GPS poll. It is standards native presence logic, CM aware, RAN informed, AOI scoped. The payoff moment is detection. Upon detecting a change of the UE presence in the area of interest, the AMF notifies the subscribed NF consumer. The notify carries two linked facts: the UE presence in the area of interest and the new UE location. Presence answers the zone question. For example, the UE is now inside the subscribed AOI, or presence has flipped relative to the last known state. New location answers the finer where exactly in network terms question the consumer may need for the next policy or session action. This is why the service is called Mobility Event Notification, not continuous telemetry dump. The interesting instant is the change. Entering the commercial district matters more than 100 identical still here samples, unless you explicitly subscribed to a mode that wants ongoing reports within the duration and count limits. Design takeaway: write your consumer logic around state transitions. Idempotent handlers, clear last known presence, and a plan for what to do when location is updated but presence did not change, or when both flip together. Worked example 1: session management and a commercial zone. Imagine an SMF that should upgrade a user's user plane treatment or trigger a local edge breakout when the UE walks into a downtown commercial district. The SMF is authorized, so it sends NAMF event exposure underscore subscribe. Event reporting type UE mobility on area of interest. Area of interest, the cell list and RAN nodes that cover that commercial district, not the whole city. Event reporting information. Condition equals UE moved into the AOI. Mode oriented to event triggered notify. Number of reports and duration set for a shopping day window. Notification address, the SMF's event callback. Target, the specific UE of that subscriber session. The AMF watches CM state and NG RAN updates. When presence flips to inside, NAMF event exposure notify arrives with presence and new location. The SMF can now adjust the PDU session path, steer to a local UPF, or arm a promotional edge application. Notice what the SMF did not do. It did not scrape cell IDs itself. It declared a contract and reacted to a clean event. That is the point of mobility event exposure for session control. Worked example 2: policy control and a hot sector. A PCF wants to tighten or relax QoS policies when UE density and mobility churn spike inside a known high traffic cell sector. Think a transit hub at rush hour. Population behavior matters more than one VIP device. Subscription shape changes. Event reporting type still centers on mobility related to an area of interest, but now the AOI is a tight list. One sector's cells, maybe a single RAN node identity. Reporting information shifts toward a longer maximum duration, say a peak hour window, with a higher number of reports and a mode suited to ongoing mobility activity inside the zone, not only first entry. Target of event reporting becomes a group of UEs, or any UE in scope, depending on how the operator authorized the study. Notification address points at the PCF. As notifies stream in, the PCF correlates mobility events with load. It can push policy updates that favor voice retainability, throttle elephant flows, or prefer certain slices in that sector. The teaching contrast with the SMF example is intentional. Same 5 parameters, different type emphasis, tighter AOI, different reporting caps, broader target. The API is stable, the product intent lives in how you fill the fields.